Hello, this is Mr. Henry, and welcome to lesson 4.12. In this lesson, we're talking about special types of linear systems. We're still talking about these systems of equations. The essential question says, how do I find the solution to special types of linear systems? And in the warm-up, it says, back in 4.3, we saw that some equations can have one solution, no solution, or infinitely many solutions. If you remember, that's when if you're solving an equation, it's like 3x plus 5 equals 3x minus 2, and if you subtract 3x on both sides, the x's cancel, and we got like 5 equals negative 2. Well, this had no solution. And there's a scenario we could have one solution if you like x equals 3, and a scenario you get infinitely many solutions if you variables cancel out and you have 8 equals 8. Okay, so the question here is asking, how might this happen with a system of equations? So how could a system of equations have no solution or infinite number of solutions or one solution? I mean, I guess in the past problems, the ones we saw in the last lesson, all the problems we saw had one solution, right? The intersection point. So how is it possible that there's no solution or an infinite number of solutions? I guess we'll find out. We have two vocabulary words here. The first of them is a system of linear equations. That's the same vocab as the last lesson. So it's just two or more equations with the same variables, and we'll be solving them simultaneously. And the second one is parallel lines. So two lines in the same plane that do not intersect. So two lines that they occupy the same space, but they do not intersect. They have the same slope. I mean, some familiar examples people think about are like railroad tracks. They go the same direction. They don't intersect. Now, railroad tracks can be curvy and lines aren't curvy, but you get the idea. They're lines that go the same exact direction. They never intersect. They never touch. They have the same slope. And that's kind of important. That's something that most people don't think about when they think of what parallel lines mean until you start getting into algebra and you start thinking about slope. They are two lines with the same slope, because if I have one line that goes up, let's say it was up 2 over 3, up 2 over 3. Well, for another line to be parallel, it has to have the exact same directions. It has to be up 2 over 3, because if the slope is not the same, eventually that line might slant yet a little bit. If it's like up 3 over 2, up 3 over 2, it's going to be a little bit too high, and eventually they're going to intersect someplace. Or if one slope is positive, the other is negative, they're going to intersect. So the only way you'll get two lines that are parallel is if they have the exact same slope. And that's a hint on one of these special types of problems if you have parallel lines. The first problem we have here says, example 1, solution of a system with parallel lines. So that leads me to believe that these two lines are going to be parallel. I don't know, but we can figure it out. How about this? We already know this guy is in slope-intercept form. This is our slope. This is our y-intercept. Let's take this second equation and put it into slope-intercept form. So we're going to solve for y. So I'm going to start by subtracting 3x. We have 2y equals negative 3x plus 10. Divide by 2. Y equals, let's see, this is a fraction, does not divide, so I'm just going to leave it as a fraction, negative 3 over 2x. 10 divided by 2 does work, and that's just 5. Now, we have the equation now into slope-intercept form. Boo. I didn't want the circle around it, but I can fix it, I guess. There. We have the equation slope-intercept form, so now this is the slope, and this is the y-intercept. So look at these two equations. Same slope, different y-intercept. So if I graph the first one, or the one on the right here, the one that's in black, the y-intercept is positive 1, and the slope is down 3 over 2. Down 3 over 2, and I'm out of space, so I'm going to do the reverse. Up 3 over 2. So this is the graph of my first, or I should say it's actually the second equation, the equation, no, that one. The other equation, the one in blue, is the equation y equals negative 3 over 2x plus 5. So I need to have an intercept of 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, here it is. And then the slope is the same, negative 3 over 2. So I'm going to go down 3 over 2. Down 3 over 2. And blue line this time. Oh, that blue. And look at that. Those two lines are parallel, as we predicted they were, because it says parallel lines here, and they had the same slope, which is what the vocabulary was hinting us at. So all the clues are telling us that these lines are parallel. And yes, there they are. They are parallel. They do not intersect. So what's the solution to this system of equations? What point, if I make a dot, here I'll make it in red. What dot, what point on this graph where will both of these lines have the same x and y value? So where on here? I mean, this point is not on either line, so that point's not true for either of them. If I put it over here on the blue line, well, it's true for this first equation, but it's not true for the second. If I pop it onto this black line, it's true for the second equation, but not the first. So where on here could I put a point that is true for both equations? The answer is nowhere. This problem does not have a solution. There is not a single point you could come up with that makes both of those equations true. This problem, or I should say this system of equations, has no solution. It's no solution because there is no intersection. There's no point where the two lines are going to crisscross. There's no point where they're going to have the exact same x and y values. So there's no solution. Letter B. I would like you to try this letter B on your own. Hopefully you kind of get the idea. So this is also practice with the graphing stuff still. So graph your two lines and check. Are they parallel? See if you can find an intersection point. Go ahead, pause the video, do it on your own. You ready to continue? Hit play. We'll go through it together. Okay, so this first equation we can graph. He's already slope-intercept form. Y equals mx plus b, just as a reminder, where the m is the slope and the b is the intercept. So the intercept is 4. 1, 2, 3, 4 on the y-axis. It is the y-intercept. And the slope is 2. As a fraction is 2 over 1. And so I'm going to go up 2 over 1. And I can't go up 2 over 1, so I'm going to have to do the reverse. Down 2 over 1 the other way. Down 2 over 1 the other way. Down 2 over 1 the other way. Alright, and that gives me my blue line like this. Okay, the other problem I'm going to do in red. First thing we need to do is we need to solve the equation for y. Get the y by itself. That makes it slope-intercept form. That way we can graph it using the slope and the intercept. So let's do that. Add 6x. 3y equals 6x plus 6. Divide by 3. y equals 2x plus 2. All right. And this slope as a fraction is 2 over 1, which looks familiar. Hint, hint. They have the same slope. So the intercept here is 2, 1, 2. The slope is up 2 over 1, up 2 over 1, down 2 over 1, down 2 over 1. If I take out a nice, pretty red line, we see that they are indeed parallel. And so where is a point where both of the lines have the exact same x and y value? The answer is nowhere, because they don't intersect. So this problem also, just like the last one, has no solution because there is no intersection. There's no place where the two lines have the same values. There's no solution. Okay, so far we've seen with a system of equations you can have no solution, as we've seen in these past two problems. We can have one solution, as we saw yesterday, or I say in the last lesson, where the two lines intersect. We say that one point right there, that's the point of intersection. That is the solution. The other possibility is here. So let's graph this first, and we'll see what happens. So first things first, I'm going to graph this first one. It's already in slope-intercept form, so I'm going to go, the intercept is 2, 1, 2 on the y-axis. The slope is 1/2, up 1 over 2, and in reverse, and in reverse, and in reverse. Dig us out a nice pretty blue line. There we go. Okay, so the first equation is graphed. There it is. I'm going to graph now the second equation, but first we need to solve for y. So I'm going to subtract x. Negative 2y equals negative x minus 4. Divide both sides by negative 2. Cancels. Y equals. Alright, negative 4 divided by negative 2 is a positive 2. And this negative 1x over negative 2, this doesn't divide. 1 divided by 2 doesn't divide, but I can simplify it as a fraction. It's just 1/2. Just negative divided by negative is positive, so 1/2 x. Okay, so I have my slope, I have my intercept. So I have an intercept of 2, 1, 2, so that might be the point of intersection, we'll see. And the slope is 1/2, so I'm going to go up 1 over 2. Interesting. I have 2 points of intersection. And that one, and that one, and that one. In fact, every single point along this line is a point of intersection. My two lines are directly on top of each other. Ah, did you see this? Look at this equation and that equation. They're identical. Y equals 1/2 x plus 2. It's the exact same equation. Did you notice that? And because it's the exact same equation, obviously it's going to have the exact same line. So what's the solution then? I mean, do I just pick one? Do I say, oh, well, that's the first one I came with, so that's the point of intersection? The answer is 0, 2? Well, no, we can't do that because, yes, that is a solution, 0, 2, but so is that one. That's a solution of, what's that? 2, 3, and that's a solution of negative 2, 1, and that's a solution of negative 4, 0. But even like right in here, that point is a solution. That's a point 1, comma, what's that? 2.5, and that's a solution. And right there, and right there, and right there. In fact, there's an infinite number of solutions. Every single point, even the ones we can't see, if we would zoom in really far, every single point along this line, even the decimals and the fractions and the ugly numbers we don't want to think about, all of those are solutions to both equations because the equations are the same. So if I plug in an ugly number and it works for one equation, it would have to work for the other. So the answer is every number is a solution. Or there are not every number, actually. There's an infinite number of solutions. The reason why I can't say every number is a solution because that point is not a solution. It has to be a point on the line. So every number is not a solution, but there is an infinite number of solutions. Every point along this line, and remember, this line does not stop here. It keeps going that way forever, and it keeps going that way forever. So even out here, there, and there, and there, all of these and all of these are still solutions to both of them. So in this problem, it's an infinite number of solutions because the lines overlap. They're directly on top of each other. They have the exact same formula. So if something is a solution to one equation, it will obviously be a solution to the other because they're the same. Here's one for you to try. I'd like you to graph these two equations, please, and then find the solutions. When you're ready to continue, hit play, and we'll go through it together. Okay, so first equation first. That one's already slope-intercept form, so I liked it. This is my slope. This is my intercept. My intercept is -2. Black's probably not a good color. -2. And the slope is -1/4. So I'm going to go down 1/4. Down 1/4. I can't go 4. I can make a guess. 1, 2, 3, 4. There's a guess. But I can go the other way. So I'm going to do the reverse. Up 1/4 and reverse. Up 1, 1, 2, 3, 4, and reverse. You only need 2 points to make a line. The more points you have, the more accurate. We talked about that before in previous lessons, I think, when we first started talking about graphing. So 3 points is good, 4 points is better, 2 points is okay. I mean, 2 points is sufficient to make a line. But the more points you have, the better chance that you didn't make a mistake. All right, other equation. Solve for y, so I'm going to -4. Ooh, what am I doing? Minus x. Those cancel. 4y equals -x minus 8. Divide by 4. Those cancel. Y equals, you probably guessed what's going to happen since the title is the overlapping lines. It's the exact same thing as the last problem. But if you didn't, yes, this is -1x. So -1/4x, because that fraction does not simplify. It does not divide. So we're going to leave it as a fraction because we like our slopes as fractions. And -8 divided by 4 is still -2. And you guessed it, the slope is -1/4. The intercept is -2, just like the other equation. So our line is going to be the exact same line. They're going to overlap. And that again means that the solution to this problem is every single point along the line. Now, we can't really name every single point along the line, but we know that there's an infinite number of solutions. So that we can say. There's an infinite number of solutions because the two lines are exactly the same. Therefore, their solutions will be the same. So every number that, or every pair of numbers that works in the first equation will work in the second. So let's kind of organize our thoughts here. So I have a little graph here, a little table here for us. So intersecting lines would just be two lines that intersect someplace. So you can just draw some random intersecting lines. I'm going to draw, there's this one, and in red, there's this one. And honestly, they don't even have to intersect at a nice pretty point like this. A lot of times, it might intersect at something like that. And that's okay. We don't know what that number is, but it's still a valid solution. So what do we know about this graph, about this type of intersection? I'm going to make it at a pretty point just for now, whatever. So we know that this type has an intersection. We know that the has one solution. The graph has one solution, that point right there. So there's one solution. And the only way that that's really going to happen, and this is another good important note to put down, is if the two lines have different slopes. If the slopes are different, it means they're not parallel, so they have to intersect somewhere. So, different slopes. So that's what we could say about these intersecting lines. There is an intersection, there is one solution, and that's that intersection point, the x and y coordinate right there, and they have different slopes. Okay. Parallel lines. Well, let's have one line here, and another line here. Okay, so my two lines there are parallel. So what do we know about them? We know that these two lines have no solution, or I should say there's no intersection. And because there's no intersection, there is no solution. There is no point that works in both equations. And the defining feature of these parallel lines is that they have the same slope, but they have a different y-intercept. I'm going to flip back a page or so to show you when we were talking about parallel lines that the slopes were the same, but the intercepts were different. So here we go. Same slope, different intercept. So they're going the same direction. One is just higher than the other. Same slope, different intercept. So one line was higher than the other. That's what makes these lines parallel. They have the same slope, different y-intercept. Because of all this, there's no intersection point, therefore there is no solution. And finally, these overlapping lines. I'm going to make the first one a little bit thicker. We'll go here, the slope of 1/2. That. Okay, and then we'll change to red, make it a little bit thinner again, and the same slope. There. That way you can see both lines, sort of. So these overlapping lines, what do we know about them? Well, we know that there's not one intersection. There's not no intersection. They're intersecting everywhere. So there's an infinite number intersections. Every single point along the line, they are intersecting with each other. Because there's an infinite number of intersections, there's infinite solutions. So that's where you can tell. And how can you tell? By looking at like a formula? Well, extra line. They have the same slope because they're kind of parallel. I mean, they're going the same direction. They also have the same y-intercept. And I guess essentially you could say, I'll put one more down here. It's the same equation. Now, the only thing you have to watch out for is when you talk about equation, back here, these did not look the same until you put them in the same form. Remember, to compare two things, they have to be alike. Well, here's one in slope-intercept form. Here's the other once we change it to slope-intercept form, and now we can tell that they're the same. So they had the same slope, they had the same intercept, they're the same formula, the same equation. Therefore, they're overlapping. There's an infinite number of intersections. There's infinite number of solutions. So now, you don't even have to graph in order to tell if there's one solution, no solution, or infinite number of solutions. All you have to do is figure out, do they have the same slope? If they don't have the same slope, that means they have to crisscross somewhere. If they do have the same slope, they could either be parallel or overlapping, because they're going the same direction. And then, if they have the same slope, just check, do they have the same y-intercept? Are they on top of each other, or are they separate from each other? If they have a different y-intercept, they're parallel. There's no solution, because they're never going to intersect, they're never going to touch. If they have the same y-intercept and same slope, they're overlapping, which means there's an infinite number of solutions because they're on top of each other, so they intersect everywhere along that line. And that's actually what these last couple problems want us to do. They're just giving us equations, no graphs anymore, and they want us to know, or they want to ask to find out, do these equations have one solution, no solutions, or infinite many solutions? It doesn't even say find the solutions. It just says determine if it has one, none, or an infinite number of solutions. That's it. So let's get to this. So basically what we're going to do is we're going to take both equations and make them look the same. The way that I would do this, I personally like writing in slope-intercept form. I think that's the easiest form. So that's how I'm going to do it. So I'm going to start by just saying, well, I'm going to put the 5x plus y equals negative 2 here, and the negative 10x minus 2y equals 4 there. I'm going to solve both of them for y to make it into slope-intercept form, and I'll be able to tell if they're exactly the same. So minus 5x minus 5x. Y equals negative 5x minus 2, because these do not combine, because this bottom guy has an x, the top one doesn't, so they're not like terms. And that is done into slope-intercept form. Y equals mx plus b. So my slope is negative 5, my intercept is negative 2. Second equation. Let's see, I'm going to add 10x, negative 2y equals 10x plus 4, divide by negative 2, divide by negative 2. These cancel, y equals, let's see, 10 divided by negative 2 is negative 5x, 4 divided by negative 2 is negative 2. All right, so I have my two equations. So let's see, do they have the same slope? The answer is yes. So since they have the same slope, they're either parallel or overlapping. Do they have the same intercept? Yes. That means they are overlapping. These two, I mean, if you look at the equations, they're exactly the same. So these two are overlapping lines, which means there's an infinite number of solutions. And that's all we have to do. We don't have to find the solutions, obviously, because there's an infinitely many of them. We can't find all of them. Letter B. I'm going to erase this red equation. So if you need it, pause the video first. Here it goes. The letter B, I'm going to do the exact same thing. So I'm going to separate the equations into two equations, or into two separate spaces, get them both into slope-intercept form, and determine to see which one, or if they're parallel, intersecting, or overlapping. And y equals -3/5 x plus 2. I'm going to do the one on the right side first because it's already done. That is slope-intercept form, y equals mx plus b, where the -3/5 is the slope and the +2 is the y-intercept. Okay, on the left, solve for y, subtract 5x, 3y equals -5x plus 6, divide by 3 on both sides, cancels, y equals -5/3 x plus 2. Alright, where -5/3 is the slope, +2 is the intercept. Okay, so do they have the same slope? Well, the slopes look similar. I mean, they both have a -5 and a 3, but no, they're not the same. 5/3 is not the same thing as 3/5. So because these two lines have different slopes, they must intersect. So if they're intersecting, crisscross, there is one solution. And if we needed to, later on, we could graph it to find the solution, but it doesn't want us to. Here is letter C for you. Please pause the video, do this problem on your own, figure out if it has one solution, no solution, or infinitely many solutions, and when you're ready to continue, hit play, and we'll go through it together. Okay, so let's separate it into our two separate spaces, y equals 2x minus 4, and -6x plus 3y equals -4. The first equation is already slope-intercept form, with 2 as the slope and -4 as the intercept. Second equation, we're going to solve for y. So I'm going to add 6x to get rid of a -6x. 3y equals 6x minus 4. Divide both sides by 3. And y equals, that gives me a 2x. That gives me an uglier-ish number, like -1.33333. So I'm just going to leave it as -4/3. I don't feel like changing it to a decimal. We could, I suppose, but it doesn't really help us or hurt us either way, because all we're doing is looking to see, do they have the same slope and the same intercept. Alright, so slopes, 2, 2. They have the same slope, so they're either parallel or overlapping. Intercept, this one's crossing the y-axis at -4, the other one's crossing the y-axis at -4/3. So that's not the same thing. Therefore, these two are parallel, and there is no solution. Summary asks, how do you determine whether a linear system has one solution, no solution, or infinitely many solutions? Basically summarizing what we just did in the past couple problems. Go ahead, pause the video. When you're ready to continue, hit play, and we'll go through it together. Alright, so I said, you can tell if a system of equations has one solution, no solution, or infinitely many solutions by comparing the slopes and y-intercepts. If the lines have different slopes, there's only one solution. If the lines have the same slope but different y-intercepts, then they are parallel and have no solution. Finally, if both lines have the same slope and the same y-intercept, then they are overlapping lines and they have infinitely many solutions. This has been lesson 4.12. Thank you for watching.